and is a manager.
Presented this morning, so I'll skip my introduction again. But now talking about tracking exploit kits, so an application of the metadata talk that I gave this morning. So why track exploit kits, right? Why bother with this kind of research, right? As I alluded in my first talk, right, I focus on criminal threats and prosecution and disruption of the online criminal marketplace. And that's kind of what I've been focusing on the past 4 or 5 years, right? So occasionally, you know, I actually do get arrests. Things get taken down and disrupted and gotten rid of whole and entire. So as an example, Operation Tovar, which took down Game Over Zeus and CryptoLocker. I was involved in the CryptoLocker pieces of that, but that investigation took about 8 months. The end result is that malware is gone. That actor has not been seen again, hasn't been arrested, but is under indictment, and a $3 million US bounty has been placed on his head. But ransomware, right, is certainly still here, and if not, you know, as prevalent, more prevalent with Locky and Cerber and several other variants that we've seen. To do these kind of prosecutions takes a great deal of time. With CryptoLocker itself, that investigation, from the time I picked it up to all the other nations getting involved and the indictment being released, took 8 months, right? And that is remarkably fast as far as computer crime prosecutions go, right? As a result, really, there's only a limited amount of things that we can go after, right? We were going after Game Over Zeus and CryptoLocker. There were other banking Trojans, Vautrac or NeverQuest. There's certainly other families of ransomware that we didn't go after because we were focusing on that one thing, right? But the reality is that for criminal enterprises, really, malware is delivered only 2 ways, by and large, right? You know, there's phishing, email-related lures, which is its own topic, right? And web-based exploit kits, getting people to get to a website that will use some exploit to download malware. Those are the 2 prominent ways malware gets deployed in the wild, right? So my thought is, why not see if we can, you know, disrupt or destroy an entire ecosystem of how computer crime happens to create not just disruption in one criminal operation, but several at a time, right? Here's just a big graph of generally from the financial perspective, an entire ecosystem of online crime, right? And the things to take out of this, right? You've got exploit writers, you've got people who write injects, people who write the malware, the people who operationalize and run the infrastructure that the malware sits on, people who generate traffic to the exploit kits, people who are money mules, moving money around national boundaries. There's reshipping, all sorts of these pieces that take place in its own discrete economy in ways that operate in any time of economic ecosystem works, right? There are buyers, there are sellers, and there are people who focus on specific things, right? Because unlike even 10 years ago, right, the number of different skill sets needed to accomplish computer crime, right, fraud, is too many to be encompassed in one organization. So you have people that focus on moving money and money laundering and money mules. You have people that focus on malware, people who focus on infrastructure. And if that ecosystem doesn't really work, right, then you're creating disruption across many things at once. It also provides opportunities to track the interaction between those entities based on metadata and other artifacts of their ecosystem, right? So just a bulletproof or a bullet list of the various aspects or roles in an online criminal ecosystem, right? Selling of compromised websites and generating traffic and malware writers, you know, carters and mules, right? The people who operate the marketplaces, the forums and like on the dark web to where people can buy stolen credit cards or get money muling services, right? All of this is needed in order for it to work, right? And if this ecosystem were disrupted, right, you would have impacts all over the malware ecosystem. What really got me thinking in these terms is I was operating, you know, an investigative group on Angler, the Angler exploit kit, and we were starting to just get going, And then one day we wake up and Angler was no more. The service just disappeared. It took some time to figure it out, but it was because the Russian authorities had arrested, a specific hacking group known as Lurk, right? They didn't run Angler, but there was only 1 degree of separation between Lurk and the people who operated Angler, right? So when the Russians, in a relatively unprecedented way, arrested 50 some odd people associated with Lurk, the operators behind Angler threw up their hands and walked away. It was like, this is too close for us, and it is too atypical behavior for the Russian Federation authorities, who generally don't arrest anybody involved in cybercrime unless there's targeting of Russian nationals, right? That's kind of a known dynamic with many malware writers who are based in the Russian Federation persist over the long term because they technologically prevent their tools from being used against Russian citizens, right? Because of this, Angler went away overnight. All of the malware delivered by Angler was heavily disrupted, right? Now, the reality is Neutrino and now RIG have taken up that load, so the EK, the exploit kit ecosystem is still there, right? But there was a great disruption. So the thought is, why not focus on these kind of things and create tools and intelligence to make these kind of operations easier and more streamlined so law enforcement can do things to the ecosystem itself instead of targeting one specific malware family, right? So as such, right, created, this research project within my organization. It has 2 particular intelligence priorities, right? The first thing, being a commercial entity, I need to make sure my products are up to date and tracking the latest threats that are out there, right? Exploit kits are delivering new malware samples all the time to make sure that my detection logic still works. And if something new gets delivered, right, I have it, can be reverse engineered, start protecting my customers against something new as it is exposed in the wild, right? The second, which we're going to focus more on in this talk, right, is developing intelligence to track the EK ecosystem, right? Their operators, their customers, all the pieces of it, right? To create hopefully some body of information that can be used by law enforcement or others to disrupt the ecosystem as a whole, right? As versus going after one malware family. Very briefly, right? I imagine most people in here know what an exploit kit is, but basically a set of tools, usually web-based, exploits some classes of vulnerabilities in Java or Flash, or the browser to install malware on a victim machine, right? The exploits they use are relatively static. There isn't that much change. It's not very fast moving because the exploits still work and consumers don't patch browsers. There's still exploits out there for 2012 vulnerabilities that are still getting traction out in the wild, right? Occasionally they use zero-day exploits, not often, maybe once a year. I think the last time I gave this talk, the day after I gave the talk, one of the exploit kits started using a zero-day. It happens occasionally, right? So if you're monitoring exploit kits, you also have visibility in finding zero-day exploits and creating mitigations there, right? The exploit kit marketplace itself, the operators, are really just selling a service, right? That sold a number of infections. I would go to the RIG exploit kit operators and say, I want 100,000 victims of whatever piece of malware I'm operating, right? That malware command and control, that's on me. They're just simply selling infections, and they're selling by count. And that has some very important implications for how they operate that we'll talk about, right? The defense against this is relatively simple. If you're fully patched, right, generally exploit kits is less bothersome. Almost all the exploits are older. As a list of exploits, RIG, Neutrino, Nuclear, Angler's gone. There's actually about 50 some odd exploit kits. There's an ebb and flow in it, but the big ones are on this list, right? And each of these have their own discrete set of operators. So they would need to be tracked individually. Okay. The first piece of metadata, right? Almost all malware that's distributed through exploit kits has some campaign ID configuration item, campaign ID, affiliate ID, something to track. This malware was configured to be sent through RIG, right? so that the operator of the malware has some means to validate the exploit kit is delivering on their promises, right? Some malware has its own affiliate system, so those affiliate identifiers may identify, not by name, but identify the specific person in an affiliate operation, right? Usually these configuration items exist independent of delivery mechanism, right? If I'm a malware operator, I don't really care if I'm going to RIG or Neutrino. I want infections. I may go to both. I may use a spam botnet also. So tracking campaign IDs and affiliate IDs and correlating them to delivery mechanisms gives you the first bit of intelligence about a specific criminal operator, right? Are they associated only with RIG? Is that the only place I see this malware with an affiliate ID? Or are they using all of the above, right? Locky, for instance, has been spammed out through Kellyhouse, which is I don't know how many years. It's a long existing spam botnet, but it also goes on a variety of exploit kits. So I know something of who's behind Locky. They're using whatever they want just to get infection counts, right? So correlating that across delivery mechanisms gives us the first piece of insight into the economic ecosystem behind exploit kits. Here's an example of a config of Locky. Many of these not particularly related to this topic, but I mean there's hashes of particular sections of the PE. The seed there is 6721. Many of you know that Locky uses a domain generation algorithm, right? That seed is what the variable that goes into that DGA to create domains, right? Tracking that seed across delivery mechanisms might give me some information. The first variable up there is affiliate ID, numeric value of 3, right? Between seed and affiliate ID, I can start mapping by delivery mechanisms to say, hey, I've seen all of this on RIG and Neutrino, which means this person is just buying EK traffic wherever they're buying it, right? This previous slide was basically part of our Barncat data mining service of mining configs out of malware, right? So all malware has configurations. You can get those items out and then start mining that for correlations, right? But cross-correlating that by delivery mechanism, right, gives you some economic visibility behind EKs, right? So that starts to be the raw building blocks of how you could do a Angler-like takedown, right? Find a group that's closely associated with one and only one exploit kit and then target them, hoping that the disruption would also disrupt the exploit kit also. As a basic process, I said this shouldn't be news. A victim clicks on some vulnerable, compromised website. There's usually a handful of redirects that gets them to the ultimate goal, right? But there's some validation of suitability of the victim, right? Part of that is simply vulnerable software. Are they exploitable by Java or Flash or whatever? But there is some decision making that's not entirely transparent that the EK exploit kits engage in for suitable victims, right? So for instance, many exploit kits will only allow an IP address to be infected once, right? The only web browsers or IPs that are going to exploit kits multiple times are security researchers, right? There's not a use case for victims doing that. And me, a buyer of an exploit kit service, doesn't want 100,000 infections on the same machine. They want 100,000 different infections. So just IP checking is something that's involved. I mentioned also, right, the sensitivity of infecting people in certain geographical boundaries. You might want to avoid infections in Russia to prevent law enforcement response. You may be targeting victims in certain geographies, right? If you're engaged in banking fraud, odds are you want to defraud certain classes of banks in certain countries, right? So you will buy that kind of service. So there's geo-targeting and geo-blacklisting, right? And blacklisting of sandboxes and security researchers. Eventually, the victim is directed to an actual exploit, and then there's a downloading and an installation of malware, oftentimes more than one. As an example of how this looks on the network level, this is the magnitude exploit kit to download server. You see the first page, there's a redirect to the 195 or 185 IP address. You know, typical Rush Cranian bulletproof hosting IP space. And then eventually, you know, through a series of redirects, right, it downloads server, right? And this is just from malwaretrafficanalysis.net, who does a lot of network-based analysis of exploit kits, right? Many of these EKs have their own discrete patterns that you can develop with regular expressions in terms of how they craft their URLs. So given that, you can identify this is RIG versus this is neutrino simply based on the URL pattern. These change relatively frequently, so a particular PCRE doesn't last over the long term because it's simply just arbitrary convention. It's nothing that has to be static, right? But you can create these patterns to sit there and say this is nuclear versus something else, and this is what, six examples of PCREs of varying complexity, you know, of what nuclear would look like. I did mention, right, there is blocking of security researchers. So to track exploit kits requires the use of a non-attributed network, right? Or something where the IP rotates relatively frequently, right? You know, aside of the fact that I've been essentially banned from using my own company's colo because I keep getting it blacklisted by research, you know, you still ought to do this outside some other network with some relatively benign looking set of VPN end nodes to start getting, you know, non-attribution so that you don't get your IP address blocked, right? Because you still want the intelligence, right? For whatever particular reason, most, but not all exploit kits really don't block commodity VPN services like IPVanish or Hide My Ass or any of the number of ones that are directed towards consumers, right? Can certainly create your own VPN end nodes and deal with the complexity of rotating your IP address. You know, the advantage of doing this is now I can appear in whatever geography I want. So if I want to start seeing what malware do I get if I have a German IP versus a UK or a Polish IP versus a US IP, I start having that ability just by using a non-attributable network, right? There is some complications running Cuckoo, you know, having the VPN inside of Cuckoo, namely you're adding runtime as the VPN is established for each run. So I set up the VPN outside of Cuckoo on the infrastructure. The problem I get is that it creates some difficulty in rotating IP addresses. I can't do that each run, so I do it as each batch happens, right? So as an example, you know, it should surprise nobody. I'm using Cuckoo for this analysis. This is just basically a list of URLs run through Cuckoo. You see, you know, the first one downloads malware, but successive runs don't, right? Because it says, I've seen this IP address before. I'm not going to keep giving you payload. In part because odds are you're probably a security researcher, and two, right, people are paying for infections. They want unique individual victims. And if EKs aren't delivering on that, then there's another EK who will. Okay? One of the difficulties we had is that there's no good central management for many Cuckoo instances. So what we had to create is basically, all right, I've got a Cuckoo exploit kit tracker for US-based and a discrete installation for other geographies. So we simply had to horizontally scale this and then basically create scripting around it, right? So there's multiple physical instances used. Okay. Now each exploit kit has its own patterns of exploits that it uses, its own selection, right? There are many CVEs all over the place to infect commodity, typical user things of Java, Flash, Adobe, and the browser, right? Every exploit kit has its own different list of which exploits it uses, right? So obviously, it goes without saying, to get Cuckoo to actually execute the exploit kit, you have to have vulnerable versions of stuff on there, ideally calibrated to what a specific exploit kit wants to see and wants to use, right? There is a tracking spreadsheet out there for last year of all the exploit kits and all of the exploits they use. The URL is there, and I think these slides will be published for attendees later. Contagio Dump is working on a 2016 more relatively new version of this. So certainly take a look at that blog. And Contagio Dump did the previous version too, for something more up to date for that particular resource. This is just a small subset of that spreadsheet. It's very large and complicated. But you can see, right, there are some things that are used in a lot of exploit kits. The bottom one, which is what, CVE 2013, 2551. But they all have subtle, slight differences. So you can also profile exploit kits by their particular exploits, right? You can also make some interesting correlations and inferences based on if the specific exploit is the same across exploit kits. There is a very defined skill set in our industry of people who are very good at writing exploits and exploiting software and writing 0 days. It's a relatively rare skill in information security. I don't know if there's any exploit writers in the audience. You may know a few. The criminal ecosystem has the same issue, is that there's really only a small number of individuals who are really good at writing exploits. Anybody can use Metasploit, but somebody's got to write the module. That community is small. So if you could start targeting those people, right, now you've got some very interesting disruption that you can do, right? If they can't exploit new stuff, eventually all of these things go away and we don't have to worry about it anymore. Okay? So the easiest way to do this tracking is have VMs calibrated specifically to whatever exploit kits you're looking at, but you still need to pay attention for new exploits, right? O-days happen every now and then. I want to say 2 or 3 weeks ago, I think RIG deployed an O-day exploit for something. It's usually not done very often because 0 days are quite expensive and valuable. Throwing it in an exploit kit is waving your hands in the air and screaming, saying, hi, I've got an O-day, Microsoft or Adobe or whoever, you ought to reverse engineer this and create a patch. So one good way to guarantee your O-day doesn't last very long is throw it in an exploit kit. But it does happen, right? And you need to be mindful of that. Okay. The next piece of this, right, is going for the landing pages and doing some decoding of that, right? Every exploit kit has particular different nuances in terms of how they craft the landing page where the victims are, right? There's an open source repository for Neutrino, Nuclear, and Angler, though Angler is defunct because Angler is no more. Running this against the initial flash file of the landing page gives you tons of configuration and metadata on a wide variety of things. What the exploit payloads are, where the controller is, the encryption keys. And from here, right, ton of data which you can create more correlations, more intelligence about what the ecosystem looks behind the screens, right? What is the economic relationship between these pieces? Here's an example, kind of an iBleed chart, but basically these scripts run on Python. You point it at whatever SWF file or landing page, you get tons of information out of it, right? So this part in the middle here, right, the back URLs, all sitting to the same place, .co.uk domain, where it's got lots of exploit payloads that you can take a look at. This will also dynamically create payload files that you can examine individually, which is what this next file looks at, right? From here, XXD, standard hex editor, nothing special, but you can look at the specific exploit payloads. If the exploit component of that is the same across multiple EK kits, well, now you know you're talking about an exploit writer who's associating with multiple exploit kits, versus I only see this particular exploit associated with RIG, which means I might be able to craft an operation to target RIG's exploit writer. That is a very valuable person. If I can put that person in jail, I've created real disruption, not just to that person's life who's operating in a criminal ecosystem, but that entire component of the criminal marketplace, right? It is a very rare skill, so now I can start targeting the weak links, so to speak. So among other considerations, I'm sure some of you have used Cuckoo, generates a ton of information about every run. Every API call, processes starts, closed, just tons of information, right? If all you're doing is running Cuckoo against a web page to see what fires, you don't need a lot of it, and you can strip that out simply to save the space. What I'm most interested in is landing pages, dropped binaries, and a couple of other pieces of metadata to create some tracking ecosystem behind it, right? You know, what's the chain of URLs that a landing page goes through? What's the PCAP? I don't really need to see API calls because it's going to be identical almost all of the time, right? I'm not using this to sandbox malware. I just want to get the malware. I'll data mine that individually and separately. I just want something that I can point a bunch of URLs at, run very fast, and gather all that intelligence. So all the logging was turned off on this, right? And then you can run Yara and or volatility to identify those dropped files, right? Is this Locky with the same configuration I've already seen, or is this some new version of ransomware, right? And again, right, the importance of using a non-attributable network so that you don't end up getting blacklisted. The most important piece of this, right, is the inputs, right? You know, Cuckoo doesn't do anything unless you tell it to run something or go to a URL. So you've got to input landing pages and feed this rig with something, right? And there's a variety of ways to get that, right? One of our biggest issues in security is we're reactive. We see an incident, we figure out what's behind that incident, we can start processing things, right? So certainly the telemetry I get from my customers, okay, these are all the landing pages identified because they fired exploit kit rules in my product. Okay, I can fire that to Cuckoo. But there's already been an infection event. It's not nothing, right? It's just not particularly proactive. So you can manually work backwards from an infection event, right? You know, the forensics team or SOC guys can say, hey, this thing was infected with ransomware. Well, this is the URL that started all. Now we can feed that through, right? It's not nothing, but it's kind of reactive. I already mentioned there's PCREs. You can work from web proxy logs or telemetry from security products and say, you know what, this matches the nuclear EK. We're going to go feed this to a nuclear exploit kit tracker, right? Not bad. You know, it's less reactive because hopefully there's not an infection behind it. You know, web proxy logs will show the traffic, but if you're not vulnerable to the stuff, there's no infection. Okay, that's not bad, right? I'll take that, right? You can use a web crawler to just programmatically scan the entire internet for exploit kits. Very thorough, incredibly inefficient, especially if you're doing that crawler across multiple geographies, which you ought to get the global perspective, right? But we'll talk more about that in a second, right? Or you can trick the exploit kit itself to give you its initial gates. There has to be some central management somewhere so that the operator of the exploit kit or the compromised web pages knows what their active web pages are. And if you can go after that infrastructure and exploit it, in essence, right, it will programmatically just give you, this is all the active stuff. So we'll talk about that in a second, right? Working backwards from an infection, right? It's a lot of what we do, not terribly efficient, very reactive, but it's the first source of data that we have. Something bad happened, let's figure it out, right? The problem is those initial gates are transient resources. They may only be valid for hours or days. If you're working backwards from an infection event a week later, right, you may be out of luck, or months later for that matter, right? What's the average dwell time of malware before detection in most enterprises is measured in months. It's not measured in hours and minutes. So if you're doing this well into the future after an exploit, right, you're going to have limited results, right? And it's only limited to what's attacking your customer or your sources, right? You don't get any geographic viewpoint of it, right? You don't get any of the other details you might get from getting a global perspective of the data. You can certainly use PCREs to hunt, right? Less reactive than waiting for an infection, but still requires somebody to be directed there. Most of the time, though not all the time, most of the time these pages generally wouldn't come up in normal web surfing, right? So going back to this page, right? This looks like a DGA-related domain, the musico prooflin. That's not something somebody normally would visit, right? So you can wait for somebody to go there, but they've already been redirected there. The start of the exploit chain has happened, right? It may be interrupted with something, and that's good, right? But it's still somewhat reactive, right? The problem with telemetry and web proxy logs, again, right? There's a selection bias in the data that you have. Everyone has their own user base, and there's demographic biases involved, right? You know, my company tends to be mostly North America, Europe. You know, we don't have good visibility in Asia what things look like. We don't sell into Russia. We'll never sell into Iran. I'm not going to see what things look like over there, right? And that gives you some blindness, right? As an enterprise, that matters less. As a security researcher, I want to see the global perspective if I'm going to law enforcement to say this is what's going on. I want to be able to sit there and have a conversation with Russian law enforcement. This is what your citizens are seeing. They don't care what my citizens are seeing. They care what their citizens are seeing. You can use a crawler. It's not overly difficult to create web crawlers. It's a relatively known technology. Just uses tons of bandwidth, and it's relatively inefficient to run your own. And there's not a whole lot of value there, right? But it does have a global footprint, right? You know, it will see everything that you feed it, assuming you've done it right. The good news is that for at least this research, I didn't have to create my own web crawler, because one of the good things Microsoft does, if you're part of their threat intelligence program, is they provide you metadata from the Bing crawler as it crawls the internet and finds malicious or suspected URLs of things that the Bing crawler is seeing, which is crawling the entire internet every day, right? A couple of months ago, when I created the first version of this slide, there was roughly 26 million malicious web pages identified, right? Global footprint all over the world. A lot of that is more than exploit kits. Additional categorization has to be done. I guess the one thing that I have a problem with the way Bing does this is there's no real categorization of the data. It's just this stuff is bad, and it just could be, you know, otherwise suspicious advertiser behavior using JavaScript, right? One of the biggest adopters of highly obfuscated Java tends to be ad tracking, which is, you may have privacy concerns about that, but it's not particularly criminal, right? So there has to be some other categorization that has to be done in processing. This is essentially what it looks like, right? Timestamp, URL, IP address, ASN, country code, and one of their identifiers of malware network or ES, a couple of others that they have. Nothing sufficient in its own right for targeting, but at least a corpus to say, you know what, now I'm not crawling the entire internet. Now I'm just processing 26 million things already identified for me as suspect, and that is a much more manageable problem. So as an example, there's about 500,000 of those URLs that pointed to IP addresses in China, right? Now, as you see in some of this data, right, the domain pieces of it is repeated, right? Because a crawler looks at web pages and makes decisions. So there may be multiple web pages under a domain that's suspect, but that's okay. I can manage that problem, right? So you would need to filter on PCREs or other things, right? So we'll talk specifically about PCREs. You could certainly run it through curl through whatever security product you have to get what the traffic looks like after multiple requests of building a web page, to also create a categorization you can use to limit that 26 million to purely exploit kit traffic. Okay? So dealing with compromised websites and bulk malicious behavior, is a difficult prospect. I don't know if anybody here has tried cleaning up ISPs of a lot of infected websites, but there's tons of infected websites out there and tons of vulnerable stuff out there that's being churned all of the time. And there's much more in terms of potentially compromised websites than we would ever have the means to clean up. But if you could properly filter it, right, then you could do things like, hey, of these 26 million IP addresses, 100,000 are this AS. I can send to GoDaddy or whoever, whatever hosting provider says, you might want to think about cleaning this, right? That is a very important resource. I do want to point out, Shadow Server operates a service that if they see any infected or compromised or vulnerable behavior for a net block, you can subscribe to your own NetBlocks reports so that you can start, it's still reactive, but at least you're getting notice every day to say, hey, there's X stuff on my network I need to remediate. Using one of the PCREs from before, right, can create a filtered list of exploit kits behavior or exploit kit landing pages, right? And here's a partial list based on August 4th, right? Now I can feed this into Cuckoo, start getting download malware, validate that it's actually exploit kits, validate that maybe it's already been cleaned, and start gleaning some intelligence that way. The last point I did want to bring up is tricking exploit kits or some of the generators to give you their compromised pages, right? If you're in the business of selling compromised pages to an exploit kit operator, right, there has to be some management infrastructure. You have to have something that says, hey, go to these 5 pages, some central server of inserting a JavaScript redirect or whatever on a routine basis to give the traffic to rig. Right? There needs to be something to manage it. And with all software, right, there may be vulnerabilities to which you can trick these services to give you what those compromised websites it's currently managing, right, at a point in time, right? Here's an example of 4 web pages that I believe were used by RIG, at least when I generated this, right? So I hit this, I get a list of URLs, can immediately feed that to Tracker and start getting dumped malware, start generating that intelligence, and it's a very high confident list. Of course, I'm relying on an exploit and operating somewhat in a gray area of using somebody's criminal infrastructure in a way they don't intend, right? But at a certain point, I'm not sure that that criminal is going to call the FBI on me either, so I'm not particularly worried. Right? So this is all the pieces, right, of using weblogs, the Bing crawler, EK bugs to put this into a sandbox, start gleaning all of that intelligence, right? Using a non-attributed network, multiple rigs to get a good geographic idea. Ultimately, there's many countries in the world, so you have to pick and choose. I can't run 190 Cuckoo rigs for the entire EK infrastructure, but I can pick 5 that are interesting and simply change it if there's ever a need to do it. Can retrieve that first page and start doing the processing and gathering the intelligence, right? Can start tying that drop malware to a specific EK or specific EKs, right? To where I could say, you know what, I can go after this EK that's highly correlated with this malware to maximize disruptive effort, right? Often the same landing page will drop other malware, right? I could look at this to start getting up-to-date ideas of new malware as it comes out, and I can mine that malware for intelligence to correlate to other malware delivery networks, right? So that is my presentation, right? If you're interested in disrupting EKs, I do have a research group on this and some other intelligence sources. I'd be happy to take any questions.
Okay. I have a question around the 0 days because I'm aware that they don't use it so frequently, right? Have you seen any correlation on the reason behind why they deploy it in which particular moment? Is because the older exploits are not working as they want it, or because they have a special requirement of a special actor that says, okay, I want to guarantee 100% infections or something like that?
The short answer is I've only been doing this a few months, so I don't really have the historical footprint to really make any conclusions. The only really 0 day that's come up since I've started doing this as the one I think Rig used two or 3 weeks ago. So I've not seen that since I've started, so I don't really have a good historical base to make any good judgment. Aside of saying that 0 days are quite expensive, so in general they won't use them because the lifetime of a 0 day after being deployed by an EK is measured in days, if not hours. So, sorry I don't have a better answer for you. Other questions?
Nie widzę pytań, także thank you very much.
Well, I don't see any more questions, then thank you very much.